Today, we're going to talk about readable code, how to measure it, why it's important, and how to turn your unreadable, messy code into nice, clean, productive, readable code. So let's get started. Unreadable code is a common complaint among software developers, and it is one of the main contributors to technical debt. Abandoning readable code is one of the reasons engineers love working on a brand new greenfield project. There's no messy legacy code to deal with. And you've probably heard comments like, it would take me longer to understand the code than to rewrite it from scratch. And this sentiment is unfortunately all too common in our industry and illustrates the problem with unreadable code, right? It slows down the development process. Now, some comments about nomenclature. Some engineers refer to readable code as clean code. In our opinion, readable code and clean code are basically the same thing, and the term readable code is a bit easier to understand and therefore more readable. So why is unreadable code a problem? It feels like a subjective opinion, right? What's readable, what's unreadable? But there's a concrete business impact on software projects, right? It's not just some fuzzy concept of technical debt that engineers are complaining about. Specifically, we want our code to be readable to speed up adding new features and bug fixes to our project. Thus, readable code should not only be easy to understand, but also easy to change. For example, recently, I was trying to figure out a feature and how it worked because I was working on a bug, and I spent several hours figuring out where in the code all the feature code was, what it was doing, etc. In the end, only to realize that it was effectively a documentation bug. The feature wasn't documented properly. And unfortunately, I made no improvements to the code base, so the next developer that tries to figure out this feature will likely have the same problem. And pro tip, this next developer could be myself 1 year from now when I have forgotten everything that I spent my time learning about this feature. All right, let's talk about metrics, right? Engineers and managers want to see metrics, right? We want to see metrics for readable code, metrics for technical debt. So there are several metrics we can use for code readability. The ideal metric, of course, would be the time it takes for someone from looking at the code to understanding it, but this isn't easy to measure. So here's some proxies. One, time to fix a bug. So measure the time from when a developer starts working on a bug until the bug fix is ready for the code review. You can even try to measure the time when they start working on the bug until their first commit, because sometimes people make multiple commits, and a first commit is a good proxy that the engineer understands the code. And similarly, there's time to fix a bug. There's also time to add a new feature, basically usually a bigger slice of time. Basically the same idea as with bug fixes. Then also there's the time to onboard a new team member. Measure the time from how long it takes a new team member to make their first commit. Now, this metric is largely useful in large companies where you have a lot of engineers, so you can get this metric. There's also code style violations, right? Your code base should have some code style guidelines, and you can measure these violations by using linters or static analysis tool. For example, long functions, long files, deeply nested control structures, poorly named variables such as 1 or 2 character names. But of course, I do have to mention that instead of measuring these code styles, you could try to enforce them in your continuous integration pipeline. Most languages do have linters that can update your code automatically and make it more readable. All right, so those were the 4 metrics: time to fix a bug, time to add a new feature, time to onboard a new team member, and code style violations. Let's talk about how to make your messy code more readable. As a general guideline, readability is not a goal by the process. If you go through code and make it more readable, next time you come back to that code, you may see opportunities to make it even more readable as situations change, features get added, or you yourself understand more context about the goals of that code. And also, you can't make your whole code base readable overnight, but you can start making incremental progress whenever you touch a piece of code. And another thing to think about it is most often there's a power law principle where most of the code changes, let's say 80% of the code changes are going to happen in 20% of the code, right? So if that 20% of your code base is more readable, that will make a huge improvement to your engineering velocity. All right, let's talk about the big problem, poor software structure. Just like I mentioned before, it took me hours to understand the feature. And one of the reasons it took me hours to understand is because this feature was spread out along multiple modules in our code base. So here's a picture. We have this big service module that has most of the code that comes in from the APIs, and this feature code was one part of it. It's actually more than one part of it. There was another part of it, and that part was being delegated to another module. I mean, this wasn't bad, but of course this module itself had other code that wasn't related to the feature, at least not related, but more related than this code. Then we have a database module. We have a large database module for all the functionality, and one of the parts of that was this feature code. Then there was this kind of hidden module, was part of a scheduler that was used, and that contains some feature code. And I do have to mention, this is just the code I found. It's quite possible there was some additional feature code in some other module that I didn't find. One of the challenges here is that I actually had to use grep to put in some keywords and hope I get to the files that have code relevant to this feature, as well as actually tracing the code through the functions and actually trying to use the code and seeing what kind of print statements I get from the database. When the code is spread out like that, when the feature code is spread out like that, it could be quite hard to understand it, and it's also quite easy to miss something. So what do we do about this? Well, let me make a couple more comments. So this type of poor structure often arises when we hurry to implement a feature and don't consider future developers needing to make changes. And it's kind of a reactive software design. Basically, you need to implement the feature, you do it as fast as possible, and you keep doing that for every feature until you get so slowed down because you can't understand that you react to that lack of understanding by going and restructuring your code. And basically, this cycle repeats itself. In this case, ideally what should have happened is once the developer implemented this feature code, they should have, right then and there, while they still had the context in their head, go ahead and refactor that. So this is how we would have refactored this code. Basically, pull out all the feature code into its own modules, one or several modules. And then basically these arrows are basically delegates, right? You could still have this big database module that knows about everything, and in a function call, it could simply delegate the responsibility to a dedicated feature module, same as with other modules, right? We can still leave those alone, but just pull out the feature code into its own directory, its own, one or more files. Therefore, it's all in the same place. And as developers are going through their code in these modules, there's no distracting other code to deal with. as well as making the rest of this code is a little smaller, right? Because these things could get bloated if they have hooks into every feature. All right. Next thing is, let's look at a smaller scale, right? We talked about some structural software design. Larger scale, let's look at smaller scale, is basically refactoring local code for understanding. When entering a function, you should quickly understand what it does. So the function code should be readable, right? And if an engineer goes into a function and can't understand it, well, it's probably too complex and should be refactored. Right? One reason long functions are difficult to understand is because they require the developer to keep a lot of information in their head. There's a lot of implementation details and temporary variables that you need to keep track of. And oftentimes all these details get jumbled and confused before the engineer can even grasp the big picture. It can be very hard to read large, complex functions. So instead, we should refactor these extended functions into smaller functions that ideally do just one thing, right? Because each individual small function is much easier to understand, largely because of its size and hopefully because it just does one thing. And on the bigger level, we will hide all this complex logic in these smaller functions. In addition, you want to use some descriptive names because good names make the code self-documenting and reduce the need for comments. I'll talk about comments some more later. So let's go ahead and jump into an example of some refactoring I did. And I'm going to reorganize this a little bit. But one thing I do want to mention is, or reiterate, is that this is a process, right? I refactored this once. Next time I come around to it, I can probably improve it some more, and if I don't forget, I'll mention things that I'd want to improve. All right, let's use blue. Okay, we come into this function, and what do we see here? We see, because blue doesn't quite work. Let's do green. We see this SQL statement. So right away, as we enter this function, we get into this detailed code. Like, we don't know when it's being called. We see a bunch of details, a bunch of additional names before we even have a high level picture of what's going on. I see that these statements are all together. So there was some attempt at organization, put all these SQL statements together. There's also this historical idea, and in some languages you have to kind of define your variables at the top of your file, but that's not the case for most languages. So I would prefer to see this detail next to wherever this insert statement is being used. All right, let's scroll down. Basically, all these details, we're going to move next to where the code that's using all these statements resides. Let's move on to the next detail. Is this statement. We're taking this is a pointer. We're checking if it's not null, and we're converting into an uint. Once again, this is, trivial, but kind of unnecessary at this point. Like, okay, we made this variable, but we don't use it until I don't know. I'd have to like search and find where this is actually getting used. It's like we're doing some logic, but we're not using it at the next line. So why did we put this logic here? In this specific case, what I actually would want to do is I would want to let me see how I solve this here. That's okay. Okay, here the way I solved this in the refactoring is I actually pushed this logic, this simple logic, I pushed it down into into other functions. So you see it here, you see it here. I'm pushing it down. This is one solution. I do still see that this is a pointer up here. And what this means that this function here has to be effectively duplicated inside each of these functions. They're actually methods, but I'm going to use functions and methods interchangeably. What I could have done is made this a different type. Instead of pointer unit, I could have made it its own type that could either return a pointer or return this 0 or value of the pointer, right? In retrospect, that's what I should have done, is make this its own type. Okay, let's move on. Here we have some code which I ended up pushing down into a function. So what does this code do? We got some incoming declaration. That's from the function name coming in, and we're turning this into an array of names and then a map of names. So basically we're taking the same data and we're making different versions of it. So I went ahead and made it in its own function, which I called enrich declarations. And this basically is a structure that contains the original value in addition to these variations of the original value. And next thing, this part of code, basically this part of code went into its own method out here. Get existing declarations. And you could have guessed from this variable name, so it's not bad, but this is a bit cleaner just to see the entire function and what it does, and just read the function names to figure out what's going on here. Let's see. I ended up keeping the next part of code. In retrospect, I could have refactored it, and I'll show how next. And then the rest is kind of the same idea. I took chunks of code and moved it down to its own functions here: delete obsolete declarations, then insert or update declarations, and then this additional update declarations label associations. That's basically it. So like, this function wasn't terrible, right? You could read it and understand it yourself. It's only how many lines? Less than 200 lines, so long but not terrible. But this new version is way more readable. All right, let's move on. Next, I want to make a quick comment about testing, unit and integration tests, right? From a readability perspective, tests are another form of documentation, so they show how the code is supposed to work. And tests should also be readable, and basically these same restructuring and refactoring principles apply to tests. Another essential benefit of tests is they allow us to refactor code with confidence, right? The previous refactor I just showed, I was able to confidently do that refactoring because we had tests for that method. So when I checked in the code, the test succeeded. I was confident that my code didn't break anything. Unfortunately, that means if you have code that does not have tests, that either you have to write tests or do manual testing to make sure your changes, your readability changes, did not break the code. All right. And then the last thing I want to mention is comments, right? Comments should explain why the code is written and not what the code does. What the code does should be effectively documented in the names of your variables and the names of your functions. Of course, sometimes there's a blur between why and what, so feel free to err on the side of commenting. So let me go ahead and show another example, because sometimes you've got comments that are unnecessary. So let me show an example where that would be the case. So we've got this code right here. So let's go ahead and pretend we refactored it. So I'm gonna keep this code on the left side. So that's the code over here. Suppose I refactored this. Let's go ahead and edit this. And instead of this, I also moved it into its own function. And I renamed the variables to names to keep. And the function that has the code now is called names of declarations to not delete. And it'll take these existing declarations from the returns from the previous method, as well as these enriched declaration that I created. So this is how I would refactor this. So now what do we see? We see this comment, figure out which declarations we should not delete and put those into keep names list. Okay, well, the function name is names of declarations to not delete. It's effectively the same thing as here. Like, this comment is completely unnecessary. The second thing we see is I renamed the variable, but the comment still has the old name. So this is one of the issues with comments, is you can refactor sometimes automatically, but the comments can tend to get stale and in some cases, like this case, inaccurate. So this is not only a duplication, but it's also an inaccurate duplication, right? So in this case, the right thing to do is to completely delete that comment. All right, let's talk about some language features that make the code less readable, right? And I want to point out, because some languages are by their nature less or more readable than others, and there's also some language features that could make the code less readable. So I'll give one example from Go, because I'm familiar with Go, but same principles apply to other languages, which may have their own readability issues. One thing I can think of, like I mentioned earlier, some languages require you to declare all your variables at the top of your function, which is a readability hazard, right? Because you want the variables where you're going to use them and not just in a semi-random list on top of your function. All right, so here's an example from Go. Let's jump to my IDE. So Go has this feature called nested functions. So a nested function is written like this. So inner func, it could have a list of parameters. Oops, writing in a different language. Could have a return, and the body could be many lines. All right, so imagine you come into this method. And the first thing you see is this nested function. Right away, you see this nested function, and you see all these details. Let's pretend this is 50 lines of implementation details. And it's kind of the same problem as I was showing earlier with those SQL statements, is immediately you're hit with these details out of context. You don't know where this is used. Maybe it's only used once in a special case, and you really usually don't care about it, right? You don't see the big picture. So immediately you have this cognitive load that slows you down, right? Like, this feature of Go language is, I would say, unreadable. Makes your code unreadable, to be precise. Right, you can have some many lines of code here. And then somewhere you would use this. Maybe you have a loop, or maybe you just use it directly. And then maybe you've got a bunch of other code. And then you return. So what can we do about this? Not sure why it's complaining. Missing return statement and the function. Okay, yeah. Okay, what can we do about this? Well, the simplest thing to do is just not to use nested functions, right? We can extract this and be a top level function at the same level as this function. So a top level function or a method on a struct, but the same idea there. So you can have a style rule that says don't use nested functions. That is basically the main thing you can do realistically. We can hope that the Go team will improve the situation by allowing you to do the definition of a nested function at the bottom, right? So from a readability perspective, it will be much better because you're not going to see this. You're going to see more relevant code. And then once you hit this thing, you could jump to the nested function and look at the details at that point if you needed to. Of course, it's a bad description. You want to use a good description name. But it would look something like this, right? At the end, after the return, you would have some nested functions like func inner, something like this, right? And you see the squiggly lines, not allowed, but in my opinion, it should be. Alternatively, you can see I'm using an IDE, and this IDE can help me hide some details. In this case, it's hiding the comments, not super useful. It does let me kind of collapse this nested function, which is, a move in the right direction. So maybe a move in the right direction would basically collapse all nested function by default. But ideally, I wouldn't even want to see this here. I would want this whole line to just disappear. And only when I get to this code, then, I can click and uncollapse this function, right? I want it just completely gone from my view. When I'm reading the code, I don't want to see this. All right, so we went over a bunch of stuff today. So just to summarize, how to make your code more readable, right? We talked about fixing your software structure, refactoring local code for understanding, for readability, making sure you're using unit and integration tests, making sure your comments are useful, and be aware of some language features that can make code less readable, and try to work around those or not use those language features. So there is a few additional benefits of readable code you may find after you start to consciously try to make your code more readable. First, and I've seen this already, many bugs will be easier to spot. Sometimes after doing some refactoring, the bug may be obvious. It's like, oh, why are we calling this method when this condition is never met, for example. This is one I saw recently. Also, when you're developing features, you may find that other developers are less likely to interrupt you with questions about your code, because they're adding on to your features or fixing some bugs in your older code. And then if your code is open source, it's great for outside contributors to come in and contribute, because if they can understand your code quickly, they'll be more interested, more excited about contributing to your open source project. All right, that's it for today.